Hi, everyone. Welcome back. If you are just joining this one, thank you so much for joining us today. Today, we are looking at, let me just pull up my notes, deploying AI runtimes in production. Eric is going to be taking us through this. The session is being recorded. If you would like to play it back, it will be available on our YouTube channel. And if you would like to be made a contributor, please feel free to raise your hand, or if you will start making people contributors, and if you would prefer to just remain a viewer, that's also perfect. Please feel free to drop questions in the chat, saving some time at the end to go through questions and some discussion. So with that said, I'm going to hand over to Eric. Thank you.
Thanks, Madison. So yeah, we're going to be talking about deploying the ecosystem AI runtime into production with a particular focus on doing it in Kubernetes or OpenShift, just because those are the environments we're seeing being used most frequently in our enterprise clients at the moment. So I'm going to first just share a few slides to share some different deployment patterns that we use and options that you have, and then I'll give a demo of how you can implement one of those patterns through Python. So we'll show it in a notebook, but that can then be put into whatever CI/CD pipeline you might want to run. So take that and implement it in whatever space you're wanting to do your CI/CD stuff in. So let me just share the screen. Wait, I think I might be sharing the wrong screen now. Okay. Can you see this presentation?
Yes.
Yeah. We're going to talk through a couple of different patterns and when you might use them and what the implications are. So the first one is permanently in production. So in this framework, basically what we do is we have a set of ecosystem runtime pods that are permanently running in the production environment and are available for you to push configurations to. So the idea there is to make you as agile as possible and make it as easy as possible to get changes into your environment by having these kind of deployments and pods running the ecosystem runtime image. We make it very easy for you to make those changes. The idea is that in your production environment, you'll have a number of these ecosystem runtime deployments, which can have a set number of pods or could have auto scaling configured depending on how you want to manage that scaling and whether auto scaling works given how quickly things change and all of those things. And then outside of your production environment, you'll have your ecosystem server where you configure your configuration for your production environment. And when you have that available, all you need to do is push your config into that production environment, and that deployment will then start presenting results based on that configuration. So it's kind of push of a button to make your changes. So you don't even really need a CI/CD pipeline or anything like that. It's kind of a single button click or API call to update the behavior of the runtime deployment in your production environment. Obviously, you would want controls in place around that button click. So you want it to happen when you've tested it and all of those standard things. But the idea is that the actual deployment itself is very low effort and very simple, so that there's not a lot that can break in that process. So it makes it very resilient. There is a variation on that if you are using custom pre and post scoring logic, or custom rewards functions. So those are, if what you want, the way you want the runtime behave, the changes you want to make to the runtime behavior, if they fall beyond the scope of what is kind of configurable by default, you have the functionality available to write custom code that either runs before or after your model scoring, so pre and post scoring logic, in order to influence the output from your time container, or you can also have custom reward functions that impact the way the learning happens by calculating rewards based on custom Java code. So you can kind of make the runtime behave however you want. Generally, the functionality should be sufficient, but if it's not, you have that available. What you would then do there in the permanently in production paradigm is use the just-in-time compile functionality that is available in the runtime. So you would do your code updates probably using IntelliJ, just because that's where we have plugins for syncing things between, but actually in any code editor. And then once you have tested those code changes and you're happy with them, you can use the compile API in the runtime to generate the classes for those custom bits of logic that you've written, and those classes will then be available in the runtime, and then you can do your push config update step. So if you are doing custom code that needs to be built, it does add a second API call to the process, but it's still a pretty simple pipeline and makes it very easy to make changes in your environment, have the runtimes generate different sorts of results. So yeah, that's the permanently in production setup. The next thing that you might want to do is, and this is actually what we recommend doing, is if you have a second deployment, which is your ecosystem runtime MCP, which then interfaces with the ecosystem runtime deployment that I was speaking about before. So the ecosystem runtime MCP deployment is a separate container which allows you to do a couple of things. One, the name would suggest, kind of exposes the runtime functionality using the MCP protocol. So if you want to allow an agent or an LLM to use the outputs of the runtime as a tool, then you are set up to do that. So when someone is, if you have a chat and you want to have product recommendations potentially being made in that chat, if that is what someone's intent detection is showing they are interested in, you can use the MCP deployment to allow your agent that's running the chat to get a deterministic list of offers that meet all the eligibility criteria and all that other sort of stuff you would configure in the runtime. So that's the one piece. The second is it gives you MLflow integration capabilities. So if you are using MLflow as a model repository, you can have the runtime automatically get the version of the model, the artifact stored in MLflow with the specified name and version number that you configure. So it allows for easier management of your models if you are using MLflow to store them. And finally, it gives you a place where you can, if you want to, configure custom APIs using Python. So if you don't want to use the standard invocations response API, you can set that up in the MCP, the runtime MCP deployment, and have a custom API call. We do recommend using invocations and response just because that's become the standard, especially if you are in a cloud environment. It's a standard that it's quite useful to follow, but if for whatever reason you want your APIs to look a bit different, you can set that up there. So those are three pieces of functionality that get enabled by using the MCP setup as a kind of interface before you reach the actual runtime itself, which has the config running in it. Deployment process will look exactly the same. You'll still set up your configuration and have a single button push, That push will then update the config in your linked runtime container. And if you have custom Java code for either your pre-post score or your reward functions, you can also have that be compiled, have that your first step in your deployment work the same way and do a compile and then push to have the configuration and new classes available in your production instance. And then the final pattern is something that is less agile, but we found some enterprises prefer just given their internal requirements. And that is to, instead of having your permanently in production images that you push configurations to, actually versioned images with the configuration inside them that you then deploy. That just gives you a version of like something that, if you then will need to roll back and you want to be 100% certain that the old image worked, and you have that available to roll back to. Whereas in the permanently in production, you just go back to the different version of the config and push that. This is sometimes needed just given the requirements of the environment. So how this would work then is you IntelliJ and the server make whatever changes you need to make to your configuration and also to your Java logic. You would then build an image containing those specific configurations and compiled classes and push that into a repository that is accessible from your Kubernetes or OpenShift environment, and then deploy that container, that image deployment running off that image into the environment. You would still have ideally the MCP running in front of that for all of the reasons that I spoke about before, but you would then have instead of a generic permanently into production ecosystem runtime container, you would have your whatever use case just for you version 1 container with the configuration in it. You still have the capability to push changes to these built containers deployments if you want to. In that case, you should probably use permanently in production anyway, but it is still functionality that is available if you need to do a quick fix for whatever reason. So yeah, those are the kind of 3 patterns that I thought would be useful to show. If there's no questions or anything, I'll now just show some Python code that you can use to manage this deployment in the situation where you have your runtime MCP and your permanently in production containers. Let's see like there's any questions.
No, there's no questions at the moment.
Cool.
Please feel free to raise your hand and we'll make you a contributor. Thanks.
Okay, so there's 2 different notebooks that I'm going to share. The one is for dynamic models and the second is for static models, which uses the MLflow functionality. So the dynamic models are kind of the configuration for them is passed through with the push. So there's no need to have a separate model repository for those. So you would import your ecosystem Python wrappers. There's just a couple of convenience things we're also using here, but effectively this is what you need. So your deployment management, this is for the server to set up and push deployments. This generation engine is for compiling the code. And this is for authenticating and connecting to the server. And then for the runtime, you have your predictor engine for testing, making test calls and checking things are working, and then utilities just for getting some information about the runtime configuration, and again, access for connecting to your runtime. So you would start off by setting up the parameters of the use case that you want to deploy. So you would have your environment. So this could be an experiment, pre-prod, or production. Your deployment ID, your projects. This would be your project would be where you kind of collect everything together, and then deployment is the details for that specific deployment that you're pushing to the runtime and the version. So here in their interaction science module, we're pushing the interaction science messages eco rewards deployment. We want version 1 of that configuration, and we want the setup for the experiment or dev environment. You would set up the path to your runtime. So this would be the URL of the runtime you want to connect to. In this case, it's running on Minikube just for demo purposes, but this would probably be your Kubernetes ingress or your OpenShift route to the runtime that you want to connect to, or the service. If where this code is running has access, is it kind of in the OpenShift namespace or the Kubernetes namespace, then you can use the service URLs to access them. And then if you want to use Cassandra functionality, you would specify your Cassandra connection file, your postcore you want to use, and your API configuration. If you want to have a custom API set up, then here we just authenticate to the server and the runtime. So we set up our passwords, connect, and generate the tokens that we need for the rest of the calls. So then here we see how we can get the compiled code and compile the class and have that available in the runtime. There's a couple of ways that you can do this. In this case, we kind of assume you're working in a repo with the code available here. If you instead have the code already available in the server, then you don't need a couple of these steps. Because we are taking the code from our repo, you get the details of your deployment and then make sure that the code in that deployment is the code that you have stored in this repo. So here we are opening this file, reading it and saving it to the server. And then we are compiling that code to generate the class in the runtime. So you'll see here we are calling the runtime, and then that returns a file name. So when we compile, the class is the name of the file with a unique identifier appended to it, and that is returned by the API. So we just store that new name for our class and add it to our deployment step, and then save that deployment step to the server. If you have pre-scoring logic or a rewards function that needs to be updated, then you would have similar steps for each of those. Then if you want to update, if you are using Cassandra and you don't have kind of the default connection, you can update your Cassandra config by calling the update Cassandra config API with the contents of your Cassandra config file. So this will then store that in the runtime. Ideally, you would do this somewhere where you have a PVC mounted so that it persists. If you don't want to do that, you would have to do this at every restart. Then we can update the API configuration used. So this will then update the ecosystem runtime MCP. It will update the Python that manages the custom APIs. So you can see here the API config that we use. So you basically set up whatever you want the name to be, and you can have different parameters being passed through with type checks and all those things. And you then format that and pass it through to the invocations endpoint of the runtime, and the same thing for the response. This just saves that to your runtime MCP and refreshes it so that those changes pull through. And then the final step is doing the push of the configuration. So you've got your deployment step, which we've updated for our specific environment. And then we just call the process push function, and that will, if nothing goes wrong, print out the properties file that is now kind of stored in the runtime as the configuration. And we can see if we make a call to that, we get the result we expect. Obviously, this is just kind of a single call. You can add load testing and simulations and a whole bunch of other testing as well as part of your pipeline. This just shows how to make that call so that you can set up whatever other sets of API calls you might want to make. So that's the dynamic recommender deployment setup. And then next bit is our static model deployment. So here, the change that we have is this: we will be using the MLflow integration that we have in our MCP. And basically what you do there is you're going to set up this, update this config file. There's an API that you call to store this, and you'd set your MLflow models that you want to be available in the runtime with their name, version, and the artifact path. And then when you do your push and the refresh happens, it will automatically get the versions of those models that you specify, save them into the relevant place in the runtime. Again, you may want to mount to a persistent volume claim. So you can see here, we've got stored, but we can look in the properties file. The model is specified here to use the model that we pulled from MLflow, and testing again, we kind of see the result that we've expected. And again, you can expand on this if you want to. So you can see that this is kind of, there's quite a few calls here, but this is like, if you're doing the maximum amount of configuration that you could possibly do. So in a lot of cases, all that you'll actually need is this process push step. So if you're doing everything in a configurable way, all you'll have is your package imports, your parameter configuration, authentication, and then your get the deployment step and push, and then your testing. And you can also do it through the workbench if you want to. Yes. So if you want to, you can do that through the workbench as well, where instead of having the get deployment step and push calls, you can just use this push functionality in the front end. So you can decide how you want to manage it. But obviously, if you want to have it in some sort of automated pipeline, it's much more helpful to have it available in some sort of Python code. You can also call the APIs directly and all of those things, but this is, we've found generally the most useful way of doing it if you want to have it in an automated pipeline. So you could have it that, if you have this as a Git, some sort of repo, and there's a merge request, and you update, say, this code here, you can have it run an automated pipeline that runs the relevant bits of these steps and updates your deployment automatically in your production environment and does any testing that needs to happen there. Bit about the kind of OpenShift and Kubernetes deployments. So I don't know if anyone has any questions or anything they'd like to ask about it.
Eric, maybe a quick question on scaling something like the ecogentic and then access to the LLMs in the back end. Because I mean, do we recommend that people scale it inside Kubernetes, or most companies would just use their private cloud provider for their LLM? So do you just connect to Model Garden or Bedrock or whatever, because those are all been completely commoditized almost, so the model should buy active and it runs in areas that are easily configurable with an API with rate limits and all of that pre-configured. So
so I think it would be, generally that is the easiest way to do it, is not to try and scale your LLM in Kubernetes, is to use something like Amazon Bedrock or whatever your existing enterprise setup is to do that. I think it's generally unnecessary to set up like a specific LLM just for the runtime in Kubernetes. I think generally, if you're using an LLM, you're like a little bit more tolerant about latency anyway. So like the fact that you're going from, that's generally why we worry about having everything in this, like everything in Kubernetes or whatever, so that, on the runtime, your latency is, sub 10 milliseconds. But if you're using an LLM, then your latency is going to be a bit higher anyway. So going up to somewhere like Amazon Bedrock or something I think is the easiest way to do it.
So did we also set up a scaling criteria for the ecosystem notebook stack? Because I think you probably need to scale that as well as the server then, like you would do a runtime if you're going to have an ecogentic call coming in. So we could also, because they're all connected, so the data is still shared. So it's just that the server might be scaled and then the notebook scaled.
Yeah, we would need to do that. We haven't had to yet, but I definitely think it is something that we will need to do, is scaling up the Python server if we are running the ecogentic pieces. Yeah, at the moment,
I think it's going to be an issue.
5,
6 or 1,000 or 10,000 people coming in concurrently, kind of existing like the runtime stack and so on. I mean, it's lightning fast. If it scales, it's designed to scale with the threading. But as soon as you run it through some of the Python backend, you need 10,000 resources.
Although they did, in the latest version of Python, they removed that lock that made threading very difficult. So potentially Python threading will get a bit more usable going forward. Because
otherwise we have to run Ray or something to try to fix it. And that's good. Complicates the configuration.
Yeah, but like I said, I think in 3.14, it's
I definitely can see that it's already better in performance
Yeah,
morale
yeah.
from the tests.
yeah. But yeah, no, that is something we still need to make sure we get right. Like I say, we haven't actually hit any issues with it yet, but it's definitely something we need to make sure we're prepared for.
Okay. I think one last thing maybe is that the standard connections to whatever the cloud providers databases are is not a problem. If they have existing APIs to access the data or not, or they've got existing models that they want us to gain access to, that's not a problem. All of those things are configurable.
Yeah. Everything's configurable, and if it's not, like, you can just write some custom code to do it, but we don't want you to have to do that. But it's there.
Yeah. People can do code around it. At least they get
Yeah.
control over it.
Yeah.
Maddie, that's it from me.
Cool.